to introduce myself, I'm Vivek. Um, you know, been in industry for 17 years and started my journey with IBM as a software developer in India Software Labs. Um, fell in love with DevOps, so became a DevOps solution architect in HCL, and then head of DevOps in Blackbug, which is a startup again. And I had my own startup that was way back, and been part of DigitalOcean and Microsoft. This is my uh, second role. The first role was investment and strategy, uh, taking care of investments and strategies for developer market. So it's a marketing role and also technical role. Most of you might not know what this role is, so it's an interesting role, right? Cool. Uh, now I work at Cloud and AI division of Microsoft, and as part of the CTO for Microsoft for Startups. And if you want to connect with me, these are my digital coordinates. You can connect with me here. So today we're going to talk about semantic kernels. It's pretty interesting time for the AI and ML world, right? So people who were building AI before, I interact with a lot of startups. So one of the story that startup told me was they were building things with traditional models. You know, the traditional model were giving accuracy of around 80% accuracy. At the moment LLM came, when they started using LLM, the accuracy has reached 90-95%. So they had to check all their traditional models and start using LLMs. So that is how how fast this innovation has gone through, right? So we have been all talking about AI. I just want to introduce what is AI. Another gentleman is sleeping. Let's be slow. He's taking a nap. Let him take a nap. Okay. So what is AI? So AI is nothing but basically a machine is imitating human behavior and is capable of doing something which human can do it, right? So that is what AI is. So for example, if I have to show you, very interesting. There is a machine. There is there is a flower. Flowers can be classified into different families, and you basically tag these flowers into different. You're basically labeling it and telling that this flower belongs to this particular family, and you're training your machine. And at some point in time, when you show a flower to it, it basically identifies which family this flower belongs to, right? So what is this called? This is nothing but a model. Basically you're training it, you create a snapshot of this, it becomes a model, it's a knowledge. So that is where the whole world was working previously, right? Training these kind of things, training different kinds of data sets and other things. And they were building a lot of models and deploying those models and accessing those models and using those models, right? So I just want to make sure that you understand the concept of knowledge and models, because this is very important when it comes to LLMs. I'll tell you why. So even before that, I just want to show you how the history has been, right? There is artificial intelligence, which came in 1956, and then there was a huge gap. Between that and 1997, there was machine learning, which was more from introduction to data and creating prediction based on the data, labeling data, supervised learning, unsupervised learning, and then deep learning, which is neural networks, where you created a connector connecting between different set of data, and you were able to make decisions based on that data. Generative AI is very different, right? In 2021, after a wonderful paper which came in, which is attention, it's all liquid required, or something like that. So basically after that paper, it's an interesting concept which came in, which is like predicting the next set of data based on the existing learning or based on the prompt which you provide to it. So it's basically generates the next set of relation with respect to the data which you have passed to it, right? So that is nothing but generative AI, and we have been talking about it from morning. so I'll not spend much time in that. So there is traditional model development. I did talk about this. Um, if you see one of the example here, there is classification of flower. What we did was tagging of the data. We had pictures of flowers, and we tagged that data and made the classification to different families, and then we built a task called classification task, and then we deployed it and we consumed it. Similarly, for sentiment analysis, we had sentiment data. Similarly, for different topic data was specifically for topic, right? So there were bunch of different data, and data was separate for different set of tasks which we were supposed to do, right? So they were separated, and they had different teams for this. They had different models they were building for these. So there were a bunch of things which were happening in the traditional model development. But then came this foundational model, right? So what happens when you train with all the set of data? So the data was anything: the text, image, speech, structured, unstructured, all kinds of data. And a training happened, and then transformer model, which is nothing but foundational model. The adoption was very simple. It was able to connect between different set of tasks. So if you ask for something, and you can connect to the sentiment analysis task as well, right? So there was a correlation it was able to do. And this kind of training requires huge amount of infrastructure. And if you take OpenAI, it has been trained for 176 billion data points, and that's huge, right? So that's a huge amount of data points and words and other things which it has been trained on. So basically, it is able to make the knowledge of that is pretty high in terms of the snapshot which we have taken is pretty interesting from the accuracy perspective, right? So that is what foundational model is. I'm just introducing this because this is very much important for you to learn about semantic kernel, why it is required, and how to consume the semantic kernel. So net, the story is here is basically the models, right? So we understood what is model, what is AI, what is model, and then there was OpenAI launched these models, GPT-4, different kinds of models which is there, which does different kind of things, and we are able to consume this through an API. Everybody in this room is using ChatGPT for one another. Students would be using for their assignments. People would be using to write emails. I use it for emails. I use it for various set of things which I do, even from using it for taking a summary of what I do from a Teams call which I have with my manager. I basically create a snapshot of all of these things which I need to complete a task or not. It creates a task for me directly, right? So all these things is happening through these models. But then interesting thing is you need to note is basically what is the missing link. If you just have to consume LLM and build an AI application, what is that missing? It does not have a memory. It does not have a, you cannot directly use different kinds of models, and there is no easy way to build something with AI, right? Basically, you can build it with however you want to from a structuring perspective. So that is the reason why semantic kernels came in. And this is a link if you want to go back and learn about the complete generative AI. There is a nice learning path, so you can actually take this link and complete this whole learning path to learn about end-to-end LLM, right? So I'll show this again if you want to later. But why semantic kernels, right? So the most important thing about semantic kernel is you don't have memory in LLM. You don't have storage of data. You don't have history. You cannot keep the histories of the chat which you are having, and you cannot call any APIs with it, right? It is just you just consume that API, and it basically responds to that API, right? That's all it does. So there was a need for building a framework, and as you know that we are all being developers. As a web developer, we are using a framework. As a if you are building something related to microservices, there is a framework for you to use, right? So there is bunch of frameworks which is available for you to do the development. Similarly, if you are building an AI application which consumes AI, You need a framework, right? So that is what it is. And we have talked about foundational model and AI infrastructure and everything, but there is a need of an orchestrator which orchestrates between uh, foundational model and also non-functional, right? Basically, you do not every task you do is part of LLM, right? So it can be different. So that is why you need a copilot and plugins extensible for that copilot. So basically, it is an open source SDK, which is nothing but a framework, which has support for any of the LLMs which is available out there, and also you can build with your own programming language, which you can use Python, .NET, Java, and other things, and basically it combines both the world's power, right? It is AI and also what programming language, the framework which is required. Let's see one example. What is it? So basically what it gives you is semantic kernel is basically two things. It adds brain to your application, which is the model LLMs, and also it provides you a connector basically to create memory. What is memory? It's basically storage, right? It's basically to store different kinds of conversations you are having with the LLM or within your organization, everything, right? So basically you need something to store in the data, in a database, and you should be able to consume that in a application, right? And then there is plugins, which is also a skill which is there, and then there is triggers and actions, which is nothing but different kinds of actions which you can perform. So when I say different kinds of action, there is semantic functions and there is non-semantic functions, which is native functions. I'll talk about that when we see an example. Okay, so this is how it works. Okay, I'll go step by step so you will understand it much better. So I'm creating a task. I'm going to ask the basically I've built an application and I'm asking something. What is the question I'm asking? So basically I'm asking, please create a series of tasks to complete a marketing project. Once you are done, please summarize them and send them to my team. Now tell me how many tasks are involved in this? 3 tasks, right? What is that? 1, please create a series of tasks for marketing project. First task. The second task is to summarize that, right? And the third task is to send an email. Now tell me, does sending email requires LLM? No, right? So there is 2 set of tasks which requires LLM and 1 set of tasks which requires only API integration, correct? So when you're building an application, when somebody is asking this kind of question to an application and your application is consuming that, what it has to do is to create a memory. That means create a context of this whole thing, what the user has been asking. So it is called ask in semantic kernel language or glossary. This is called as ask, and memory is nothing but a vector database connector. So it uses a connector to create everything in the store everything in the database, create a context for the conversation to happen, and then it creates a plan. What is a plan? Plan is nothing but set of plugins. So skills, set of skills. When I say set of skills, what it means, these 3 tasks are 3 different things. One of the skill is to talk to LLM for creating marketing project, and then second task is to create summarization. Now in these 2 different tasks where you are talking to the LLM, what is the most important thing you need? Prompt, right? And you have to engineer the prompt. It's not like just I'm going to send this and it will do that, right? You need a prompt engineering to be done to get the output right. So there is a requirement of building a planner, building a skill to understand what kind of prompt has to be executed, and what else is required. What happens when you're sending each prompt? So when you are doing an each prompt, you need to do settings. If you have used OpenAI or Azure OpenAI or Hugging Face or any of the LLMs, you need to do the setting called as temperature setting. You need to do max tokens, how much tokens I need to use for this kind of prompt, right? there are a bunch of settings you need to do before even you send this as part of the prompt to the LLM. It can only take one single prompt, right? So how do you structure this? That's where the developer will have to create a plan. So the create a plan when such kind of input which comes in, the developer creates a plan. So the plan is nothing but skills or plugins, what it is called. It creates a plan, and then obviously I'm using a different kind of connector called Graph API, which is also a separate kind of connector to build a task and all those things. And then there is two different things, which is semantic function and native function. Native function is where to send email, which does not require LLM. Semantic function is where you are going to do prompt engineering and do the configurations and send to the LLM. So semantic functions are those kind of functions which will send LLM prompts, and native functions are those which is to execute non-LLM kind of task. That is your traditional programming language. Whatever API calls you do, storage of data, retrieve of data, right? Those are the things which you do, right? So that is what you do from a native function. So that is the reason why it creates a pipeline, and it is called as chain, and this whole thing works in the kernel, and that is why we call it semantic kernel, because it executes with the semantic function and other things. The whole management of this is in the kernel itself. So this is the framework you build, right? So when you're building an application, what you have to do is you get an input from the developer, from the customer, right, or from someone who is consuming your application. So basically, if you see this interesting part, the input is in natural language, right? The input is in natural language, which is the main reason why we all go for LLM, right? And input is in natural language, and then it uses native functions and semantic functions and create a plan or the understanding of the skills what it has. It takes all of these things and creates a pipeline. Okay, so that is the structure. So I'm going to give you one more example of what plugins mean. Okay, what I'm asking is, can you write me a short poem about living in some place and then create a story based on the poem? So basically, these are the skills it understands. The developer has made available for the semantic kernel, that these are the skills you understand. So whenever somebody is asking such things, please execute the skills which are relevant, okay, which are relevant to the input. So it identifies which is the relevant one. So if you see here, so if I'm asking it to write a short poem and asking it to tell me, create a story based poem, what are the plugins it is going to use? Short poem and short poem and story generation. These are the two different plugins it is going to use, but it does understand rest of the plugins also. It has the knowledge of that, but it is still using only these two, and that is what it is called as planner. It creates a planner to execute what is required for this natural language input, and then executes it. So I'm just repeating what a semantic function is and a native function is. Semantic function is the one which is talking to the LLM model, and there is a response for that, and native function is basically the one which is just to save information, look for information, or perform some kind of action. By the way, LLMs don't do maths and all those things. So if you have any kind of questions which is coming from maths or doing some kind of calculations and other things, that's when you use native function. That's when you use your own algorithms to do it, right? You cannot go to LLMs to do that. How do you combine all this is what semantic function is. So basically, semantic kernel is a very interesting one, because you would have heard about Microsoft 365 Copilot, Bing, Chat, which we are using today. Most of you might be using it today. All this is built with semantic kernel. Okay, and why it is required? Why does a framework is a most important thing? Is because imagine you might have 50 prompts, 60 prompts to execute for different set of tasks, for different set of skills or plugins, which I call. It is very difficult to manage in the code. And imagine you have different set of developers who are developing all of these things, and the developer leaves, a new developer come in. If you don't have a framework in place, that means you're going to lose out on a lot of time for a developer to understand the framework or to understand the code structure, right? If you have a framework, like if you tell the developer that we follow semantic kernel framework, so it is easy for developers to go back and use it, right? Anybody who is developing in with through a framework, it is easy to understand. If you go and say we are using Django Python framework, everybody says, okay, I know how to do this, I know where is what, and what is models, and what is MVC, and everything we'll know, right? So that is how that is why a framework is required. And net this is what it does. There is a foundational model, there is it has support for different kinds of LLMs, and then there is a chat copilot which you build, and then there is a memory which is a vector database connectors and other things which it has, and then side effects which is called as plugins and connectors as well. So you can create plugins. There is already a model for plugins, there is already bunch of plugins which is available. You can also create plugins, and this is basically the structure. So basically these are the things which it does. I don't want to spend time on this, I will show you a demo. So I just want to make sure this is how it works. There's an ask, and ask goes to the kernel. Kernel creates a plan based on the input it has provided, and based on that the skill which it notes, it gathers those skill. It could be connector, it could be different kinds of connectors and context, and then it executes the plan 1 2 3 4, and that's the output it is throwing. Okay, so this is one of the example which I can share, which is like user is actually going and calling out, telling that, hey, create a query for get me the list of products from the database. He's just talking in a natural language, and then it goes into Azure speech to text, and goes to LLM, and then goes to SQL to execute that query, and then output is thrown back, or the response is back to the user through speech using Azure text to speech conversion. But by the way, if you see, all of these things can be built in a framework which is semantic kernel framework, right? So this is one of the example how you can build a application with AI and semantic kernel, and this is also one of the example which I want to show. This is again through Fabric, where database is there. You can talk to your data. Fabric is nothing but end-to-end analytics, and you can talk to the data through semantic kernels. Everything is built on semantic kernel. So basically you can keep asking questions like search order number this, and let me know what is it, and calculate today's what money we have made, and all of those things you can keep asking, and it keeps answering those questions. You can build your own copilot on top of the data which you have, right? So that's the purpose, and that's the use of semantic kernel. So even before I go to next step, I'll show you how it is built. Okay, so it's very simple. You have, this is a Python code. You can see there is couple of, you can see right at the end, yeah, you can see there are bunch of import and other things which I have made. Obviously I have created the input configurations and other things, and then there is I'm calling this particular service of the kernel, which is add chat service. So if you see this is the most important part of the code, which is, because here if you see, I am referencing a skills directory, right? I'm referencing a skills directory there, and I'm calling it as a fun skill. So if you see here, there is a skills directory here, and there is a fun skill. In this there are two different files, which is configuration.json, and then there is escape prompt. So this is the prompt which I am giving. So basically I am telling, tell me a joke now, and it has to be controlled, and this is called responsible AI, right? So you are designing responsible AI through prompt, you're controlling it, right? So this, I am only executing one skill here as an example. Imagine you are executing 50 different skills, right? So this is one skill. So basically I am doing bunch of things here. So be creative, whatever it is telling and it's taking the input and other things. And here is the configuration which is required to run this. So max token is some 1000, temperature is set to 0.8, and some parameters I have provided. It's a subject, joke subject and other things to capture the description, and also I can mention the style of the joke it has to tell, right? All of these things has been designed here. So now I'm just creating a joke, right? So let's, what should we ask? Anyone who wants to give a prompt? Let me ask this. Microsoft. Okay, I don't want to do that. Again, that is also prompt. That's an interesting. Okay, hopefully I have a network. Let's see. Right. So it did tell me a joke. Why did Microsoft hire a fortune teller? Because they wanted to know if Windows 11 and would finally be bug free. Okay. Right. Cool. So this is one type of development. This is a direct usage of semantic kernel. I am actually doing the plugin, and I am actually building that configuration JSON and everything and using it. But there is one more interesting one, which is I want to create history of conversations. I want to keep having the chat, right? History of conversations, whatever I'm having. So to do that, I'm also doing the similar kind of development, but here I'm putting a some kind of prompt saying, giving explicitly I don't know and other things. This is a chat bot and user input and history and other things. And if you see, it is creating the context and other things. So I'm invoking it and executing this as part of the so these are the three different questions which will go in part of the prompts. So basically it will keep asking these questions in a loop. So that is what I have built, right? If you have to do that, it's a basically structured way of doing it, right? So now I'll not execute this because it will take time, and I do have 4 minutes and there is next speaker. So but I'll show you interesting one. Imagine you have so you can see the skills here. You can see the skills. So imagine you have so many skills, and within some of the skills like summarization skill, I might have bunch of skills, right? So all of these have different prompt. All of these has summarization. You can see. So this has its own set of prompts. So imagine you're building an application with 30-40 prompts, with different set of inputs which you are giving. You need a framework to build it, right? So this is the kind of a framework development where you have skills which is in a folder, and then there is a code which you are executing, and then there is a native function which you are executing. So I'll show you the native function now for an example. So there is not this one, sorry. So now you can see this whole thing. So it has bunch of things. So one is for summarization skill. So this is where you're going to teach as a developer for specific solving certain things. You're going to tell it, okay, these are the skills you know. If you remember my plugin slide, there were bunch of skills it knew, right? So that is what it means. So basically you're going to tell it, these are the skills which you know, and this is what you have to do. And interestingly, this one, right? This one is an inbuilt core skill. What is inbuilt core skill? It is nothing to do with LLM. It is basically an inbuilt one. Okay, that's what it is. Got it? Cool. So this is how you need to design it. So ultimately, it is the um, plugins, and there are bunch of connectors which are already available. The connectors are for connecting to the database, connecting to the different model. As I told you, it works with different set of models, right? So that is what this means. So I'm done with it.